All right. So here we go. So if you can all mute yourselves, and then yeah, I'll give you my first take. Okay. Insulin is a hormone that delivers sugar or glucose into cells so it can be used as energy. Your pancreas makes insulin all the time. It makes more when you eat to help your body change the sugar in your food into energy for your body. If you have type 2 diabetes, your pancreas doesn't make enough insulin, so not enough sugar makes it to your cells. The leftover sugar stays in the blood, and over time, this can lead to eye, kidney, and nerve problems and heart disease. The good news is that there are medicines to help people with type 2 diabetes control their sugar levels. For some people, the best medicine is more insulin, like the insulin their pancreas normally makes. Cancer can result from multiple mechanisms, including dysregulation of gene expression. Abnormal gene expression can be caused by genetic mutations or epigenetic alterations to cellular DNA. DNA is tightly packaged into chromosomes, and in order to compress into chromosomes, DNA strands are tightly wound around proteins called histones, which fold upon themselves to form chromatin fibers within the chromosome. Gene transcription and expression depend on epigenetic processes that regulate the opening and closing of these tightly bound chromatin fibers to allow access to genes via enzyme modification or chromatin remodeling. Common types of epigenetic alterations include the addition of methyl groups to DNA, or methylation, as well as histone modifications, which can include histone methylation, acetylation, and phosphorylation. During the inflammatory process, immune and other cells produce and are stimulated by inflammatory cytokines. Some of the key cytokines important to the inflammatory process include IL-17, IL-23, TNF-alpha, and IL-36. Dysregulation of any of these cytokine pathways can lead to an unbalanced inflammatory response. IL-36, a member of the IL-1 family, has 3 subtypes: alpha, beta, and gamma. The first definitive account of GCA is often credited to Sir Jonathan Hutchinson's description of thrombotic arteritis of the aged. In 1932, Dr. Bayard Horton was the first to obtain biopsy specimens from a patient with hardened nodules along temporal arteries, and the first to identify jaw claudication. And with further research, he was the first to recognize GCA as an autoimmune disease. In 1949, Horton was involved in the care of the first patient with GCA who would receive cortisone. Although prolonged use can result in high cumulative doses, which may result in side effects, glucocorticoids have been the mainstay of treatment for patients with GCA for 70 years. In preclinical studies with mice, this bifunctional delivery resulted in more localized inhibition of TGF-beta within the tumor microenvironment, independent and complementary anti-tumor effects, and enhanced activity compared to monotherapy directed against either the TGF-beta or PD-L1 pathway. Concomitant inhibition of the TGF-beta and PD-L1 pathways with bintrafusp alpha is currently being investigated in clinical trials in multiple tumor types. There we go.